Hey, how's it going? Today I'm going to be talking about supervised learning done by AI and what that is. Supervised learning is a type of machine learning paradigm where algorithms is trained on a labeled data to learn the mapping between input data and corresponding output of target values. Um, Even that perhaps worth translating. So what we're going to be looking at is a type of learning, and that type of learning would be supervised learning compared to other types, right? It would be done by machines as well as the algorithms. So based on the key points that you yourself might be interested in when structuring those algorithms or systems, when structuring those systems, what will be key points that you would be looking out of that data. So if you have a large data set, large amount of data, how you're looking to process data and what kind of information you are looking for, and is something if that's something that you are interested, perhaps not right now, in the future, as well as what kind of information you will like to put in, as well as what kind of information you like to put out. So overall process. Perhaps once you, if not right now, perhaps in the future, perhaps for your business is something that you would like to do when doing research, for example, if you something that you might be interested in finding out more about, or doing research work right now on a paper, whatever case might be for a school, for a business, you're trying to understand what perhaps would work for whatever data you might be using for whatever purpose that might be, right? Uh, yeah, so that's how you can potentially process that. But in particular, supervised learning is something that we're focusing in within this video. This approach, the algorithm learns to make predictions or classifications based on the patterns and the relationships in discovered in the training data. The term supervised refers to the facts that the algorithm training process is guided by the supervision of labeled data, which provides correct answers or target values for the given inputs. Let's take a look at a basic overview of the key components and steps in supervised learning. Data collection. The first step is to gather the data set that consists of input-output pairs. The input data represents the features or attributes that the algorithm uses to make predictions, while the output data represents the corresponding labels of the target values. Data processing. This step involves cleaning and preparing data. It may include tasks like handling missing values, normalizing or scaling features, and splitting the dataset into a training set and a test set for model evaluation. Model selection. You choose a machine learning algorithm or model that is suitable for the task at hand. So depending on what kind of problem you have, you might be able to looking for tool that would suit the problem based on what you are looking to solve, what kind of problem, right? The choice of a model you can vary depending on the problem type, such as regression, predicting continuous values, or classification, assigning labels to data points. Model training. The selected model is fed with the training data, and it learns to make predictions by adjusting its internal parameters based on the input output pairs in the training set. This is done through an optimization process that minimizes the predictified loss function, which measures the difference between the model predictions and the true target values. I'm just trying to think about an example. What would be a good example for people out there just to help to assess what I'm sharing within this video. So if you have perhaps 7 year old, right, or perhaps at any point if you remember being within the first, second grade and you were trying to learn math, what 2 plus 2 is, if you were up there trying to understand what 2 plus 2 is, you had to come up with the best way to solve this problem, right? Where you've been guessing, so if you were guessing, that model, perhaps guessing model, is something that might work in the short term. But you could try doing that. That's potentially what there are some models that perhaps will try guessing. But perhaps from there, you need to keep redefining and perhaps sharing more data, giving more clues, or perhaps giving more structured data that would require and we're going to be more challenging to that algorithm. And that 7-year-old, right? So potentially you would give more data for that person to keep coming with a better formula to what actually 2 plus 2 is. So after you fed more data, you check the results, you keep checking the results, what that algorithm comes up with. That 7-year-old keeps challenging. Don't let that 7-year-old to go to sleep. Keep stressing you out. I'm just trying to take a funny angle. Don't do that. But either way, if you keep feeding more information, and later you would be able to check results, and after you undergo this kind of process, eventually, that 7-year-old would be able to understand what math is and how to numbers work, right? So whatever case may be, 2 plus 2 or 5 plus 5, or so it's just a matter of time. So potentially, after a large piece of data, gradually over time, by redefining the process, the software would be able to understand some of the processes involved when it comes to math. Model evaluation. After training, the model's performance is assessed using separate test dataset that is haven't seen during the training. So perhaps you would give different dividing, or whatever case may be, 8 plus 2, right? Common evaluation metrics include accuracy, mean, squared error, or other, depending on the problem type. This step helps assess how well the model generalizes generalizes to new unseen data. So whatever. So you would eventually you would like to test this model, right? With that 7-year-old kid that you love so much would be able to do math, right, and succeed in life. You need to test it, right, to make sure that the kid grow up to be a president of the country, right, or prime minister of the country, whatever the case might be. Model tuning. If the model performance is not satisfactory, you may need to fine-tune its hyperparameters or try different models to improve performance. Model development. Once a model meets the desired performance criteria, it has been developed for making predictions, which not necessarily would work for depending, but again, it depends what kind of problem you might be looking to solve. Someone to predict the future, perhaps based on the past, I guess, based on what kind of information. But either way, instead of predictions, perhaps classifications of new real-world data. Classifications might work better, but either way, supervised learning is used in a wide range of applications. For people out there who are interested in learning more, I have published this book. I would highly recommend for everyone who is interested in learning more about their body, everything what would be required in developing your own body. I have shared everything within this book. Myself, I've been in the field. I have done it. I have done it as a leisure, lifting weights. I have done it for many years, as well as I have done it professionally. I actually been earning money from doing it, so I guess that's as well as I have qualifications to train people, it's worth mentioning. As well as I have read so many different books, and in some of the books, top books, I wasn't able to find some information that I knew, so I thought I would share that with others, for people who are interested in learning more about that hardware that they're moving around in. And so you can find it in the description below, as well as Topic Does has it. Supervised learning, it can be used in different ways, as well as including perhaps image classifications, natural language processing, speech recognition, recommendation systems, and many others. It's fundamental techniques in the fields of artificial intelligence, and it's widely applied in solving practical problems where there is no need to make predictions or decisions based on available data. So there are a lot of applications people themselves working on currently. There are a lot of people, a lot of cutting edge people and different businesses as well, looking to hire perhaps more people within this space. And there are perhaps more opportunities than everyone can imagine within this space, right? Where they can outsource a lot of current requirements within the different businesses to this particular area, and how that can be done and what would be real world applications. So just name a few, right? Thanks for watching. I'll see you in the next one.